Hello everyone, I'm Ettore, and today I will interview the AQUILO Rocketry team from the Inholland University of Delft.
So, hello, I'm Kristian. I'm the manager of AQUILO for this year, and today with me is the current board of the team.
Hello, my name is Conan. I'm the head of the structural department for this year.
My name is Rob. I'm the head of the recovery department for this year.
My name is Barbora. I'm an electronics member, but also PublicRelations of AQUILO.
Hello, my name is Ioannis. I am the head of propulsion for this academic year.
And finally, I'm Óscar, and I'm the head of the electronics department for this academic.
How did your team start and then grow?
Our team started back in 2014, and it started as an internship project. After that, some other student decided that that's a cool idea for a student team, and they make it an actual extracurricular activity. Since then, we grow quite a lot. Nowadays, we're about 40 members, and we have much more complex projects and even more ambitious goals for the future. Right now, we are working on two major projects. We have AQUILO 7, which is a supersonic rocket, aiming to reach velocity of 2.7 Mach and altitude of about 10-11 kilometers, and AQUILO 8, which will be our most recent launch. The goal of that rocket is to reach 2.53 kilometers, and what's interesting about it is we're aiming to develop our own stage separation system and to see how this one will go.
10-year anniversary next year.
Yes, yeah.
So hoping to plan something for that.
How's your university? How different is it from TU Delft?
We are located inside the TU Delft campus, but the university curriculum is different. Our university is applied sciences, which means that it focuses more on the applied area of science or engineering. So we have, for example, more emphasis into the projects. We have more practical assignments than them. The curriculum is different. We have, for example, more internships. During our bachelor's, we get 2 internships, and our whole course is 4 years. Until graduation, and theirs is 3.
What's interesting also about our university is the scale of the projects. For example, right now, all of us, we are second years, and aside from the classes that we have, aside the lectures, and aside the AQUILO, we have also projects to build small-scale aircraft with 3.5 meters wingspan. So that consumes a lot of our time, and it's quite challenging to design. Also, we're working in groups, so we have to cooperate with people from all across the world, and that's also something that causes challenges sometimes.
What are your job opportunities after university?
So having the 2 internships over the course of the 4 years and doing projects for industry, actually our projects that we do throughout the 3rd and 4th year are tied to industry. Our school reaches out to companies in the area, and then those companies provide us with the projects that they want us to do on behalf of them or provide them with. And from that stem a lot of opportunities. We have very good networking, a lot of career events happening in our main project hall. And usually by the end of our study, it is common for every graduate to have 2 or 3 people reaching out right from the get-go just to get us to work for them because we've already worked for them in the past through internships and projects.
Yeah, just for example, there is close connection with Inholland and also AQUILO with companies like NLR, for example, here in the Netherlands. And it's pretty common to see students joining their group after graduation because they have already worked with them before.
What's also very common is actually us or Inholland graduates then moving to TU for their masters, for the aerospace masters, or continuing a master's elsewhere. That does involve us needing to do a prep program because of us being a hogeschool and not a university. But nevertheless, yeah, there's many opportunities, masters or industry-wise, after this program.
I'd also like to state that, for example, our bachelor's is aeronautical engineering. That is different from aerospace engineering in TU Delft. But it's true that once we reach our 4th year, we have the opportunity to specialize. And there is a space minor that Inholland provides. So it's not only limited to the aeronautical sector. You can also find quite good opportunities in the space sector.
What are your team's goals and your active projects?
Our main goal as a team is to help students from our university to learn and to grow and to develop themselves in the rocketry field overall. So we are providing a lot of learning experience in the team itself. For current projects, we have two ongoing, AQUILO 7 and AQUILO 8. AQUILO 7, the supersonic, and AQUILO 8 is a dual-stage rocket. After that, we're planning to go to a competition, which you're familiar with, I believe.
EuRoC?
Yes. That have been on our schedule, in our mind for quite some time. However, there always have been some complication and we have been delaying it. But for 2025, we're aiming to go to the competition finally and see how we will perform there. For EuRoC, we're planning to design completely new rocket. So that will require some time and we would like to have some successful launches before going to the competition. We would like first to test it here in Netherlands and then go to the competition with already tested rocket.
Working on our AQUILO 8 rocket, which is more AQUILO 8.5 because it's an improved version of the previous AQUILO 8. And we have already scheduled some launch windows for this year. So that's what we're busy with now.
How do you recruit new members to your team?
We have a selection procedure at the end of the academic year. That means around May or June, we have interviews with the current first years of the university. Those who are graduating and successfully passed the first year in our university have the chance to apply for the team. And from there, we're selecting those who we think are the most suitable for the team. Like skill-wise or just personality-wise, it's also a crucial role in order for them to be in the team. Aside from that, if we need some more people during the year, we're willing to invite certain people that we know how they work during the project. That's other benefit of the project regarding the team, that we're familiar with all of our fellow student members, our fellow students. We know how they work, how they perform in groups. So if we need some people for a given department, we know who to approach and say, hey, do you want to join AQUILO? Do you want to help us with that project? That's going to be interesting for you, going to give you some opportunities.
I believe regarding recruitment is interesting for our team, which might be different from others, is that the fact that the people can join from the second year because the requirement is to have the necessary credits in order to continue the study. So also the management positions, so in us in this case, are also second years. So we get this the opportunity to be in these positions because our curriculum has an internship in the third year, so those cannot be actually active in the team. So there's a knowledge transfer system in which we have the chance to manage the team and gain a lot of experience and knowledge.
I think the requirement for people being allowed to start only in second year is quite recent because of the issues that arose where people would join the team in first year, and then, as you probably know, rockets just kind of overwhelmed them and made them believe that that is the thing in life and the only thing, and then they fell behind on their studies. So as much as we love those devoted people and we find ourselves also spending more time in the office than in class, the school decided that so that we can all continue being students and stay on the team, we have to first make sure we are successful students, and then you can do the rockets on the side. Though that's always hard. I personally prefer working on AQUILO than homework, and I think most of us do too, but we have to make sure we can actually stay in the university as well.
And also as an additional, as Barbora mentioned, that first years are not allowed to join the team, all the first years look up to the members of the team and the team itself as something that they can achieve on the second year and be part of, and maybe have a better expertise on some of their skills or find more opportunities as internships later on.
It's this process that kind of pushes a lot of people. We've had a lot of interviews with, or at least us as well, when we were in interview for the team. I think a lot of us mentioned that the final push to study for that terrible exam was, oh, I need the credits to get on the team, so let's just push through for this one.
What can members of your team learn from the team?
The structure of the team is as follows. We're separated on 4 departments. We have electronics, propulsion, recovery, and structural. That means that the people who join have the right to select one of those departments, and therefore they will specialize much more in depth in the given field. So I believe each one of you could hear a little bit more.
Yeah. For example, regarding the electronics field in rocketry, we, as the experience we get this first year of bachelor, we are not really focused on the electronic side in aeronautical engineering the first year. So there's quite a big learning curve we have to overcome once you join the team. But that involves a whole set of skills, and not only technical. Also, you learn how to work in teams. In case you the board positioning, you also learn management skills, which I think is really beneficial.
Yes, I totally agree with Óscar. And in addition, for the structural department, we mainly focus on real-life engineering problems, such as force distribution and how to actually manufacture our rocket, because that's also our purpose of the department. And to get more practical knowledge, which I find very important, and also use the theoretical knowledge you gain in school, and use the practical and theoretical knowledge here in AQUILO.
For the recovery department, it's mostly learning the simulation softwares we use for our flight, and also a lot of making new concepts for new separation systems, for new deployment systems, which is the fun part of the recovery department.
And lastly, for the propulsion department, whoever joins our department has to learn a lot of simulations as we simulate the motor, how it burns, learn exactly how a solid motor works. As in the curriculum of the first year, we don't get into thermodynamics yet. We don't get into how a closed chamber works, only from aerodynamics part. Also testing facilities, testing equipment, how to test properly and safely a motor, how to do static fire tests, hydrostatic as well here in the university, and experiment with energetic materials, as we are able also to cast our own propellant.
I guess the one thing I can add, besides being in electronics, I guess that's the opportunity in our team, is to do a few things at once. So for myself, being in electronics and public relations, it's actually an important skill to be able to think in both mindsets. Sometimes I'm doing electronics work and completely forget that I should also be looking at taking photos for social media, or I should also be promoting other departments. So it's very important to be able to do both, as is for all the members here. As board members, you sometimes get caught up in your engineering work and realize, oh, I'm still a manager on the side and I have to do that as well. So that's not necessarily a skill that every single member gets to do, because not everyone is a board member, of course. That would be too huge of a board to ever manage. But yeah, if you do take on one of the extra positions like a board member, social media, public relations, etc., advisor as well, then you need to learn how to think both things at once, as an engineer and as a manager.
And that additionally gives you a lot of soft skills, a lot of time management you should improve on, because of course that takes a lot of time from your day. And as we're continuing to study, we're not full-timers. We don't have any full-timers in AQUILO. That means that we need to organize our time very well. So we improve a lot on that, a lot on soft skills and communication with people, with companies, on the professional side of the communication.
I would like to make an emphasis on the adaptation process that we all go through, because as I said, it's quite new for all of us. Some people may have experience in their backgrounds. Nevertheless, once you join this rocket team, there is an adaptation process, even if you're bored or not. And there is some stuff you have to learn slowly to get up to speed, and then everything rolls faster. So we also account for that, and we also try to organize it in order to make it successful.
How do you design your rocket?
That's a good one. In a matter of fact, right now we have a task force within the team, which is for designing the booster for AQUILO 8.5. Of course, as every design, we have to start with requirements and what we want to achieve with the given rocket or the given part of the rocket. Currently, with the booster, we have to set strict requirements of the altitude we want to achieve, exit velocity of the launch tower, and such things that are important for the initial design. After that, we start brainstorming ideas, developing them, and trying to make sure that the connection between different departments is appropriate. Yeah. After that, each of the departments taking their role start designing, for example, the e-bay or the recovery system or the structure of the rocket, start making simulations for the motor, for the aerodynamic performance. But the starting concept is the basis of everything.
Once the design is done or approved, then manufacturing process starts. I think Conan can tell more about this. But there's only one thing I would like to make emphasis in, and it's the importance of, for example, once a motor is designed and built, it has to be tested. And without testing, we really cannot move forward. And for that, we have specific types of data acquisition systems that we will go in detail later. Without that, we need to ensure that the data we receive from those real-life testing is good enough in order to continue with the design. And maybe you want to add a little bit about the manufacturing process?
Yeah, and basically the manufacturing is based on load cases we find. And based on the load cases, we we figure out how thick or what thickness or the strength it has to take the component, and after that we look into what's the suitable manufacturing method for the component, because not all parts can be made the same, because we are mainly focusing on composite rockets, and for example, not everything can be made out of composite. Some also have to be made out of aluminum, but we'll get on that later. And also already named, we do also simulations, for example CFD and FEM analysis to verify our calculations we made earlier.
We learn a lot from our past rockets and our past members, and that is why we made it a goal for our board this year, is to better our documentation, because it is very hard looking at previous designs or not being able to find them, and once you do, figuring out what value, what decision is crucial and which one was there just like some decisions are more important than others, and that's why we're trying to make sure that every decision we make is fully documented this year, so that for future generations they know what they should really stick to, what is a lesson learned and should be followed, and what they can change and play with.
How do you test and measure the performance of your rockets? So you use DEWESoft data acquisition systems?
We have two types of ground testing, hydrostatic tests and static fire tests. And in this case, we use a data acquisition system from DEWESoft, thanks to our sponsor Clemency, which is the Cyrus box. And together with it, we have load cells, we have thermocouples, and that's the way we can measure the performance of our engine. That's mainly what we do as ground testing and as physical testing, but of course, prior to that, there's a lot of simulation and simulation analysis. I believe that the most important factors to consider when you have to choose a data acquisition system is, first of all, a good connectivity and processing speed, which is basically what DEWESoft has to offer, and we're very thankful for our sponsors to provide us with that. Where do we test the rockets? We are using NLR. That's one of our sponsors. They provide us with a bunker, so we can do.
Just to clarify, testing. NLR is the Dutch subsection of DLR. So it is the Aerospace Research Center for the Netherlands.
Yes, exactly. Sorry. Thank you, Barbora. So they provide us with a bunker in order to safely test our motors. And we launch in a military facility, military ground here in the Netherlands.
How's the experimental rocketry community in Delft or in Holland?
Delft as a city is one of the most developed in terms of space because of TU Delft. Here on campus, you have many aerospace engineers and many people who are interested in rocketry because of that. Therefore, the community there, it's helping a lot with rising the rocketry. Therefore, it's a nice place to be if you love rockets. You have a lot of opportunities to meet people who are also enthusiastic about it.
And not only rockets, you have satellites, you have any type of launch vehicles. There are other student teams that are especially working on different types of space technology.
We are also only an hour from Noordwijk, which is the center of NL Space Campus, which is like the community for space of the Netherlands.
Absolutely.
They organize a lot of events. Used to be mostly for companies, for industry, and now, especially through our sponsor, Clemency, we're really getting to go and be a part of this community, which seemed unreal to us a year ago, but now we're there as often as we are in the office, it seems. So we have a very lucky placement for what we do.
Yeah. And just in general, the space community is growing up rapidly. Recently, we had the opportunity to visit Space Tech Expo in Germany, in Bremen. There we met many companies in terms of I'm talking about 300, 400 companies that we managed to talk to. And that made us all super enthusiastic about the future, about possibilities, about the goals in Europe in the space sector in general. And all of us are happy about the fact that Europe is catching up on the United States and Russia and China in terms of rocketry, in terms of space activities.
And adding up to what Barbara said, being so close to this space community and other student rocket teams, for example, like there, it's also very beneficial for all of us in general. We are all in contact with them, and we are really happy to share knowledge and motivation with them. So I think being in a place like Delft is definitely a growth factor for a rocket team like ours.
And not only there, but on that event in Bremen, we met many other student teams across Europe. We talked with people from Stuttgart, from Munich, from Aachen in Germany. So there are a lot of student teams that are also working in the field, in the area. Therefore, you could actually see a small community building up in there and some connection being built within those teams, which is really nice news.
Honestly, we've been a little surprised of how willing everyone is to share their information. Any team we meet have offered to advise, to help, to exchange information. So as I personally expected it to be more of a competitive market, I guess, if you can call it that. But no, the teams in the Netherlands, teams throughout Europe have proven to be really, really helpful and accommodating in everything we do.
How do you promote your team? Basically, how do you do PR?
So we do have, I guess the basic is the social media, as that rules our world right now. We have not yet gone to TikTok, although we are being pressured to do so. But currently we have Instagram page, a Facebook page, our website, and that's where mostly our Instagram page is where we keep up to date on a weekly basis. We update what has been done in work sessions, what we're working towards, give kind of countdowns to the big events that are about to happen. We inform a lot of our students at Inholland so that they stay intrigued by the only student team currently the only student team of our university. We also have a LinkedIn page, and that's where we keep our sponsors and more the industry up to date on what we're doing. But aside from the social media, I think our greatest PR tool is just attending events. So in the last 3 months, we've attended everything from NL Space Campus, which is like the monthly get-together of space industry in Noordwijk. We also attended the JEC-dag, which is the composite event for Europe, but this is specifically for Germany. So we had representatives there talking to companies, doing kind of like a meet and greet, just 16 hours over the course of 2 days of just meet every company and have a 30-minute conversation with them, through which we met a lot of amazing companies that are willing to help. And then I guess the most exciting one, which we all as board members got to attend, was the Space Expo in Bremen, Germany. And there were over, I think, 600 companies, if I'm correct.
Yep.
4 halls full of amazing space-related things that we didn't even know were being worked on. To be honest, a lot were out of our scope. We approached a lot of them hoping to connect, to learn from them, to maybe look for sponsorships or just advice. And we often came back knowing that, okay, well, we don't need 500-degree cable resistance or 500-degree resistant cables yet. But nevertheless, because there were 6 of us, I think we managed to cover most of the 600 companies. We have Leaning Tower of Pisa of business cards that along with Kristian, had to digitalize. So that took a couple of hours. But yeah, events is where we get most of our contacts, where we get most of our ideas as well.
In terms of communication, this year, thanks to Barbara, we are improving the external relations and external communication, but we also have an essential internal communication within the team. And that is mainly based on doing meetings and presentations about what is the situation of the team, so everybody's aware of it. If there is some internal concern or internal problem, it's always communicated and managed through the board. And we do have a YouTube channel that it's in our plans to improve for the future, because I know it's really appealing and it's definitely a source of attention catching. So that will be improved, but yes, there is a YouTube channel in which you can check some launches.
Currently, from the 40 members on the team, there are about 3 or 4 of us that are working on this public relations side of things and social media. And we all have our primary jobs, me being an electronic member, now task force member. Actually, we're all electronics people working on social media, so maybe there's a tie there. Maybe, yeah, electronics and public relations somehow meet. That's a relevant revelation, I guess. But we do hope, or we are considering making a separate department for it. That is yet to be discussed, but we realized how important these events are, how important social media is for not just keeping our community up to date on what we're doing, but also reaching out to sponsors and being able to grow. And we, as much as I love what I do, it's hard to do electronics and make a perfect YouTube video at the same time. Again, I'm often too busy soldering to take a video of myself. So that's something to look into for the future. Maybe get a whole separate department, and that's what we're discussing at the moment.
Yeah. Something maybe additional is that our also university helps us a lot promoting in their site, in their social media as well, and also our sponsors in the Space Tech Expo. We wouldn't have a stand to promote some of our work without the help of our sponsor Clemency. And about promotion of the team as well, we promote our team with a presentation in the first years in order to kind of give them information of what is the team, what departments do we have, how could they be part of the team in the second year. So every year we have a new presentation from the board of the year, going to the first year lectures of the English and the Dutch bachelor in order to see if they want to come into the team.
What are your plans for EuRoC?
We hope that we'll manage to design and build a rocket for EuRoC 2025. However, that still haven't started. Actually, we've been developing a system that haven't been used in any of our rockets yet, specifically the air brakes. As probably you know, the goal of EuRoC is to reach as close as possible given altitude. The goal is to reach as precise as possible those altitudes. Therefore, we need to control our velocity and how high our rocket will go. Depending on the circumstances, depending on the weather and the day, basically. Therefore, right now we are developing an air brake system, which will be implemented in our next rocket for the first time.
AQUILO 9.
Yeah, in AQUILO 9. Aside from that, we're yet to look into more critical regulations that will be expected from us for the event.
Yes, it has been in the plans before, EuRoC. As Kristian mentioned before, sadly it wasn't possible. But that means that there's people who have already looked into it, and there's people with experience, and they serve as advisors to us. So the process should be smoother this way. And we are already excited to bring AQUILO to Europe. Yeah.
And for the category, we plan on doing a solid rocket motor to 3 kilometer altitude.
What were some of the biggest challenges you faced when designing the rocket for EuRoC?
As we mentioned, we haven't started actually designing the rocket itself. Right now, we are trying to figure out how the air brake system will be implemented in our design for the future. But I would guess that wouldn't be the biggest challenge in the rocket itself. And the worst is yet to come, or the best, depends how you look into it. Because we love challenges, we love to solve those problems and find solutions for the most interesting problems that occur during the design, during the phase of meeting requirements.
What do you hope to achieve during EuRoC?
For our first participation, I would say that we would like to have fully functional rocket with all the systems working correctly. And in the future, probably we might go for winning the competition or whatever. That's really ambitious. However, if we dream big, we might get there someday.
Would you like to join other competitions like Spaceport America Cup?
In the future, depends how big the team will grow, depends on how we are doing on financing side of the team, because that requires a lot of financing. Getting a rocket there, getting many team members there, that requires significant resources that we don't have currently.
As we've already mentioned, we don't have any full-timers. On rare occasions, we get an intern, or our university accepts us to have an intern to be dedicated for one specific topic. In this semester, it was airbrakes. But because there is no one full-time, not even the board, it does make progress a little slower than on other teams that do have people working on it 9 to 5. We also have, therefore, a bit of a smaller budget than an average team, because we technically don't require the budget to be paying someone for those full-time hours or for an internship. Therefore, we hope to shoot for the stars, but at the same time, we know we are very limited in manpower alone.
How do you see rocketry evolving in the future?
I would like to see more sustainability. For example, SpaceX reusable rockets. That's especially for the goals we have set to go to Mars and Moon is a requirement. And I hope to see more of that very soon also from ESA itself or other rocket companies, small startups. Also saw lately that a company in China managed to make a hopper rocket, and looking forward to new ones.
In the future, we could look more into less conventional materials, more like composites and less metals for the rockets. That would also be a great thing for both strength and lightweight structures.
I believe that's a summary of our opinions. More reusability and better materials for the future.
And maybe, if I may add, maybe it's also more use of the AI. Nowadays you see designs being optimized by AI itself, which I also would see more in the future. And I think especially also now with metal 3D printing, you're more flexible with your design, and I think we will see that more often.
Could you give more info about your rocket?
Well, I believe here we could start by departments, just to brief overview of what we do have inside the rocket.
Yep, but for example, we can maybe talk about the name because it's interesting. The name AQUILO comes together with some other projects in the past from Holland, like Apollo. It's a Greek god for the wind. So that's the initial idea for the name of the team as a general overview. But for example, for departments in case of electronics, we work together with sponsors, as I said before, for example, Clemency in order to testing, but also inside the rockets, we are trying to innovate in systems. I will go a little bit in more detail later, for example, about the flight computer, but we are trying always to improve in terms of systems and sensors, etc., in all of the rockets. So, for example, we are busy now into jumping from third-party computers to our own designed computer, both hardware and software, and try to make all the systems work together.
From the propulsion department, we are building our own motor right now. As Kristian mentioned in the task force, we are building the booster. The propellant is already the same as we have used the other years. However, we have currently an internship about a research in propellants in order maybe to change it at some point. We have some sponsors that help us, especially NLR, about testing our motors, because it can go and be dangerous if you don't test it properly and you don't have very strict safety protocols.
For the recovery department, it's a new department, so a lot of things were third-party parachutes and third-party systems, and we're currently designing our own systems and looking into designing our own parachutes. So that's something exciting for the future, but for now, it's starting up the new department.
And then last, for the structural department, we're planning on improving our manufacturing methods we already had, or maybe finding new ones to improve our efficiency. Besides that, also get to more know composites itself, because we mainly focus on composites, and use other interesting manufacturing methods for also other materials. But we'll get on that later. And also requirements are things we're going to implement, which are very important during the manufacturing process and the designing. So that's it.
I think overall it's in our main focus to try to outsource as less as possible. We would like to learn about the manufacturing procedures, for example, as you said. We would like to have our own designs, our own improvement, our own learning. So yeah, we're working on that.
Yeah, I believe as an additional, we have mentioned before that we are in the Netherlands, we are almost in the center of Europe. And many companies have their offices here. It is very easy to find most of the manufacturing processes, machinery that we want in order to use. It is easily accessible to find sponsors in that field. As well as help from other universities. As we are in a campus, we can also have good communications with TU when we need some help. I believe, yeah.
I think it's very hard to put a price on the rocket and a price on our team of how much it costs to run it. Honestly, because of our sponsors, because, for example, our biggest sponsor is our university itself in Holland. So they provide us with the office space and the workspace. So that's covered. The same with the equipment. We get to use the composites lab of our university. So that's also, we don't really see the cost of what it takes to run those machines.
Sure.
For materials, we have a wonderful sponsor, Solvay, that gave us carbon fiber that we are now planning on using. Also, the carbon fiber we used before this sponsorship gift was often of the university itself. Though recently, after attending Jekdag, we started getting so many offers for leftover material from companies that we feel like we might be able to start selling it ourselves. But yeah, all these things are provided to us through our sponsors, or a lot of them. Of course, we have our own budget to also buy electronic systems and such, but also anything we buy is often reused. For example, for electronics, even when we had our big explosion last year, which we can cover later, we somehow managed to recover most of the electronic system, even though it was literally shot out of the rocket.
And also thanks to Structural.
Also thank you to Structural.
Yeah.
It was very impressive that you saved us all of our things from being blown up. So unfortunately we can't really provide you with a number just because so much of it comes from sponsors and from our supporters.
And what makes our entire team unique is, I think, we cast our own motors, we cast our own propellant, and we make our entire aeroshell and the nose cone fins. Most of it, we try to make as possible from carbon fiber, from composites. And that is I think, unique position within the other rocket teams.
As mentioned, a lot of times we're mainly focusing on composites. For example, glass fiber and carbon fiber itself. Our aeroshell is made out of a sandwich material, and our fins is also from carbon fiber. Our nose cone itself from glass fiber due to the frequencies, the radio frequencies, which has to come through. Besides that, we also use regular aluminum. This will be made mainly with laser cutting. For example, we're currently making our sustainer for the new rocket, and we had to laser cut our bulkheads out of aluminum, and that's also including with honeycomb and carbon fiber itself. So nearly everywhere in the rocket we put our carbon fiber if needed, because it's a reinforcement. Besides that, we also use conventional 3D printing. It is very commonly used, and also for us, it's very nice, especially for more complex geometry. And if needed, we use more reinforced materials such as carbon fiber nylon, which makes our parts more stiffer and better strength, which eventually for a launch with a lot of frequencies is a lot better than regular PLA.
What software do you use to design and simulate the engine?
Mostly for the CAD designs, we use Fusion 360, as we have a common workspace area that everyone from every department can log into AQUILO team files and work there. We have subsections for the propulsion department. We work on the design in Fusion 360, and then we use OpenMotor to simulate how the grains will burn, and grain geometry as well. We use ProPep 3 in order to simulate our propellant, how much material, what percentages we are going to use from which material. Use also RAS Aero with the recovery department this year in order to predict where it will land, but that's also for the whole rocket, not only for the motor.
Simulation-wise, for the structural department, we mainly use ANSYS for CFD and finite element analysis, which covers all our needs, which is great. And Besides that, we also sometimes do fusion and fusion itself, finite element analysis, and that mainly covers our simulations for our rocket.
What avionics do you use?
In case of our rockets, we have 3 types of sensors. We use a barometer, we use GPS, and we use IMU, inertial measurement unit. And that's basically what involves all of the avionics inside the rocket, but we also have different systems which are essential to control. And the most interesting part about this is that this year is going to be the first time that we're actually going to jump into the project of designing our own PCBs actually, our own flight computer and other necessary plugins to it, which also involves the coding of it. Regarding cameras, for example, there have been cameras in the past. AQUILO 2 had a camera on the nose cone. It was a 360 camera, but it hasn't been used again. It's definitely in the scope, not right now, but it's being discussed. And in order to make sure that our data is correct from our sensors, we have been using in the past, maybe you're familiar with it, it's egg timers, only the last year, because it was a EuRoC requirement, so we tried to stick a little bit to EuRoC requirements just in case in the future we might join. So we used third-party computers, but now that we're jumping to our own flight computer, new projects arise, and for example, we are currently busy with the Kalman filtering for data. That's I think that covers mainly our sensors and avionics.
What is your recovery system?
Till now, we've used lead powder cups and third-party parachutes because we didn't have dedicated recovery department. From this year onward, we do have the dedicated recovery department, so we're looking into new systems. We're designing CO2 cartridges for separation. We're looking into mechanical separation systems. We have a design for controlled parafoils that we might want to test in the future. And also we're looking into designing our own parachutes. So there are a lot of projects coming up in the recovery department.
What is the payload of your rocket?
For EuRoC, we've had plans to just have a dummy mass. I think they were CAN, but anyways, there's just a dummy mass in our payload bay. We might want to look into having science experiments there because it's just way more fun and it's also used for a rocket. But until now, there haven't been any plans for payloads.
And sorry, just before we move on, in terms of propulsion, because I feel like we've kind of given an overview of everything, of all the departments, but skipped over propulsion. So Ioannis, please.
I believe so too, to be honest. We could have mentioned before, I didn't understand that we are going to skip some questions. The main thing for the propulsion department is also that we are cast our own propellant. So in softwares, we don't exactly use except open motor. However, we have a lot of jigs. We have only one person currently in the team that has permits in order to cast. As in the Netherlands, the legalities to purchase this type of energetic materials are kind of strict and don't allow for every person to just go and purchase these materials. So only one person currently in the team holds permits to do this type of casting process. We use obviously our own casting jigs in order to do that. However, for the casing is bought from third parties, manufactured from companies that we buy them, as well as the nozzle converger, which is from graphite. We are not allowed to CNC lathe it here in the university, as when you CNC lathe, graphite goes everywhere, and it really needs a huge cleaning process, and the university doesn't like that, so we just place it to third parties that can provide machinery that they can help us produce these parts. Rather than that, we use also EPDM. We use rocket candy, known as rocket candy propellant, which is a propellant based with sugar, sorbitol as an example. Other than that, we have some development and innovation. We have thought about a headed ignition, however, it's still a very starting process. There is a lot of testing to be done in order to be sure that it's going to be safe enough to implement it in a motor and eventually in some of the future projects of our team and to see it in a rocket.
I think the propulsion department has been a great example of how much we've progressed, especially since the first 2 rockets of ours we outsourced our motor to DARE, our fellow student rocket team at TU Delft. So the fact that we're now we have our own department, are making our own, are casting ourselves, I think it's a great example of how much we've changed over quite a short period of time.
Do you know and play Kerbal Space Program?
I personally have played it when I was a little bit younger. That sounds terrible. I played it when I was in high school for a little bit. I didn't go into depth of it. However, it's a really interesting game. When we started here last year, in the first year, Óscar and I bought the game again and started playing it. However, we didn't go into depth again because we didn't have the time. We had to study, to focus on the university itself. I personally never dived deep into it.
Oh, but it was certainly fun because I didn't know about it before. And a matter of fact, AQUILO has opened me a broad spec of the rocketry field and the rockets in space. And it's fun, the fact that it all started with the Kerbal Space Program when we joined the bachelors. And yeah, I remember us trying to get that rocket to orbit, didn't work, trying to learn the orbital mechanics and everything. Yeah, no, but it was really fun. It was really fun.
Because this is how you started, right,
I would say that I started with Kerbal Space Program.
No, just that it was completely new to me, and I think us 4 had no idea about it until we learned about you, and through you we learned about the Kerbal Space Program.
Yeah, let's say that I started with Kerbal Space Program, and then after I started making my own sugar engines. I don't know, I spent 2 or 3 years on that. Then I started experimenting with liquid engines and failing.
Well, in my opinion, Kerbal Space Program is really a nice game. You can definitely learn a lot. In terms of orbital mechanics, there's a lot that you could actually learn from there, and it's visual. It's a game, so it's easy to grasp than reading a book. And aside from that, the structure of the rocket, a different functionality of different parts in the rocket, how to get everything together, what exactly do you need. It's a great game. If I have more time in the future, probably I will play it. For now, at least till then.
For now, your manager, don't even try.
Yeah.
Does your team have a big announcement or dream?
Big announcement, definitely the 2 upcoming launches. Next March 2024 and May 2024, we're going to have launches here in Netherlands. AQUILO 8.5 will be launched firstly only the sustainer, and then the sustainer and the booster all together, the whole system integrated. It's one of the big announcements. The other one we mentioned it, our plans to go to EuRoC. So that's in the short term and a little bit long term. We'll see in the future.
I think we're just excited to see the rocket fly with all our flags on it as well. I think we've kind of breezed over the fact of how international our team is. Just here alone, we have Spanish, Greek, Czech, Dutch, as we are the Netherlands, makes sense, and Bulgarian. And we were counting the number of, we put the flags of the nationalities of our members on our flag, on our rocket. So last year there were 5, I believe. And this year we were counting, and we don't know if it'll fit on the rocket at this point. We'll probably have to limit also people to keep one nationality. Otherwise, might as well make the rocket 6 meters tall. But yeah, we're just excited to see it fly and hopefully not blow up this time. That would be great.
Do you have any advice for young rocketeers?
Say just start doing stuff. Doesn't matter if you fail or not. It's actually that's the process of learning. Everyone is failing. In a matter of fact, you could look into SpaceX. They are failing on purpose just to learn from that. So that's the smartest thing you can do. Otherwise, if you're just reading books, that's never gonna get you as far as you can go if you start doing things and not be afraid to fail.
Personally, as a new space fan, rocket fan, I would say be curious, because never close yourself to anything. You might learn a lot by just being curious and find yourself in new places and being excited about new things. In this case, rocketry in my case. But yeah, be curious, try, and fail. Yeah.
Be safe.
From the propulsion department, please be safe.
Yeah.
I would also say, if it takes a long way education-wise, maybe you're now currently not on the current level in which you can pursue a career into rocketry, but don't give up. One day you will be there and you will be proud of yourself.
Do you have any favorite movies related to space or rocketry or YouTubers?
Star Wars. I believe we could all agree that that's one of the best. Then Interstellar.
Ender's Game.
Yeah, Ender's Game. The Martian. That was the name, right? Yeah.
Mhm.
Yes.
And I would say for YouTubers, I really enjoy watching BPS Space.
Yeah.
He is really ambitious, and I really enjoy seeing how he does that all on his own and see the progress along the way. So it's really a motivation.
And I also like to watch Everyday Astronaut.
Yeah.
He's making really good, I would say even short documentaries regarding engines and really good educational videos, how everything works in the rocket, the comparison between Russian and American engines through the years, and really interesting channel.
For me, as an additional, I agree with BPS Space. The other YouTuber that I have in mind is not exactly so much on the rocketry part. However, he has an experience in NASA. His name is Mark Robert. He's very famous in USA. He has done great things in learning young people about engineering and how to think outside of the box and how to solve problems. It is a very nice way how to teach young people and get them into the engineering field.
Do you have any questions to me?
Yes, I actually have questions for you. Probably the most attention-grabbing thing in your LinkedIn and your YouTube, everywhere when you open your social media, you can see that Elon Musk. Could you tell us more about it? What is it? How did you start? What exactly do you do there?
Yeah, so when I was younger, I believe when I was 7, I went to visit Ad Astra, which was a school that Elon Musk created some time ago. And then I did the admission and they accepted me. And then COVID came out. They moved online.
Okay, and what courses do you have there?
So it was mostly about engineering and science.
Is it more technical knowledge based or practical? Or
I would say it was more theoretical. I mean, in the rocketry class, we did, there were rocketry teams. But I would say it's mostly theoretical. Again, being an online school, you can't have much practice.
But talking about practice, do you have any advice to get more involved with DEWESoft now that we have the possibility to use their equipment? Because I have seen you are very involved in DEWESoft projects.
Well, I can always give you contacts to DEWESoft. I know very well the head of marketing at DEWESoft Italy, so then find you someone to talk with. I can try your contact with him if you're interested in collaborating with DEWESoft.
Thank you very much.
And regarding your future, how do you see yourself? Do you want to be more in the engineering or more like journalism point? I mean, career path, like YouTube channels or...
Either I want to build rockets or I want to be a researcher.
I know you still have a few years ahead of you before university, but do you know where you would like to go?
That is something I still have to decide. Definitely TU Delft seems like an interesting university, or yours. Even though I don't know much about your university, I definitely know that better. There's also the Polytechnic of Milan, which could be interesting. But well, luckily I still have multiple years to decide.
And your personal project regarding rocketry, you mentioned liquid engine.
Liquid engines is probably my only current project with rocketry. I must say that for some reason, I am not very good at it. Mostly, I tried many times to make the wish rocket and failed. I don't know why I can't make the wish rocket. Anyways, so I'm working on it from like more than a year, I would say. Also, I have managed to roast some marshmallows. I'm not sure if they count as rocket engines. I must say it's a very fast way to cook some marshmallows.
Yeah, I look at the video, indeed it is.
And then one question for me, I see 3D printing on the slide. Can you tell me more about your experience with 3D printing?
Most of my experience with 3D printing comes from the fact that I have a 3D printer, which is definitely very useful. A medium-sized printer, I would say. I print PLA and sometimes TPU with it.
Are normally your designs and objects you make, are those functional parts or more for fun?
Well, so the things that I print have a very wide range of things, from fuel injectors to tubes to nozzles that last a couple of milliseconds to like Christmas ornamentation. basically anything I want.
Very cool. Have you then also looked in metal 3D printing, but then a filament which you then have to put in an oven and which will turn then into metal after some time, after sintering?
Well, I have definitely thought about that. There's also ceramic kind of 3D printing. Yes, I have tried multiple times to build myself a furnace so that I can do casting of aluminum. I think that most of the parts that I make in metal have quite simple geometries. Just being able to cast would definitely be very useful.
Did your parents, are they in the space industry? Did they support you in this? Did they get you interested in it? Or it's been your own venture and them looking from afar, not knowing what it all is?
They they did not have much experience in space and rocketry because their jobs don't have anything to do with rocketry and space, though they do help me, yes.
Sorry, I was just kind of more as for the younger viewers, I guess, to point out you don't really need, well, of course, support is important, but you can also get there just on your own accord.
If you look into our team, what department would fit you the best in your opinion? Electronics, propulsion?
I would definitely say propulsion. I am doing electronics, but it's not the digital kind of electronics. It's the simpler type of electronics with no programming. So I would say definitely propulsion. It is definitely the one which I have more experience. I think it would be the most interesting for me.
Apart from Elon Musk school and the experience you have in Rocketry, do you research more about subjects like thermodynamics, or because those are difficult subjects, are really complex mathematics involved, and how have you tackled that?
Well, I have two tools. One is Wikipedia, very useful. The second, right, when the math is hard, you can not do the math. Well, I'm joking, but I can't really do much math. So when I do my liquid rocket engine, I can't really do much math because I basically know nothing about it. I do not know the chamber pressure, the fuel rate, the oxidizer rate. So I don't think there's an equation I could use because I don't think I have enough information.
Thank you very much for having us.
Yes.
For the invitation.
It's a pleasure.
I don't know if my fellow board members want to be exposed like this, but when you reached out to Conan about you interviewing us, it looked like Christians. They were very, very excited. So thank you so much.
In a matter of
for
fact,
meeting
I've been
with us.
following your activities on the social media for quite some time, and I know about you. And when you approached Conan for an interview, I was super happy. I was like,
I think he cried a
Yeah.
little bit. So thank you.
Thank you.
Thank you. Okay, then bye, I guess.
Thank you so much. Bye-bye.